Good afternoon, good evening, or good morning, depending on what time you're watching it. Here goes my phone. So, in the lesson on Wednesday, we're going to be doing something called Titrations. We've done this before with Dr. Evans with soap to work out how hard or soft water is. And in that lesson, you had soap in a burette, and you had water in your flask, and you basically looked at, well, my understanding is you looked at how much soap drops you needed to make the water lather, create froth. So what we are doing as part of the topic we're currently doing, chemical analysis, we're looking at how titration is actually used to work out real values, concentrations of different substances. So the setup, you will have a burette, some hydrochloric acid, conical flask, and you'll have an indicator. It might be phenolphthalein, it might be something else. And you're going to use your knowledge of how much acid or alkali is used to make this solution go neutral. So if we have a look at this situation just here, you might well have a known concentration of an acid and an unknown concentration of an indicator, and you continue to add the acid until this solution goes neutral. Now, the first time you do it, you can do it quite rapidly just to get a rough value of the known concentration required to make this go neutral, i.e. put it through, roughly it's around 26 centimeters cubed, for example. Then you do it again, but when you get close to that value, 2, 3 or 3 centimeters cubed away, then you stop and you do it drop by drop, so you get a more exact value the second time. Now, to actually work out the known values, you need to use an equation, which is the following. The number of moles divided by the volume is equal to concentration of the solution. So you need to have volume in decimeters cubed, and concentration is moles per decimeter cubed, and obviously moles is in moles, so I don't need to mention that. In any of the problems, you first of all have to know the two chemicals you're reacting together. So I'll do an example. We have H2SO4, so sulfuric acid, plus ammonia, NH3. And that reacts together to make this substance, NH4, brackets, so 2 lots of that, and SO4. Step 1, balance the equation. You must do this, otherwise all the other steps are not going to work. So how do we balance this equation? Well, all I have to do is put a big 2 here. So now I've got 2 ends on both sides, 2 ends here, and then 2 ends there. 2, 5 hydrogens, sorry, get that right. 2 hydrogens there, 2 times 3 is 6, so there's 8 hydrogens, and there's 8 hydrogens in total there. 1 sulfur and 1 sulfur, and 4 oxygens and 4 oxygens. Nice and balanced. Step 2. So step 2 is to create a table. Always looks like this. Moles, volume, concentration. And so we'll have H2SO4 up here and NH3 here. We fill in what we know. So in this example, we're going to say that the concentration of the H2SO4, we know that, and we're going to say that that's 5 moles per decimeter cubed. I'm going to say that the volume used to titrate, to neutralise the NH3 was 40 centimeters cubed. So by doing that, we can work out using the equation here what the moles are. Now there's a problem because the volume needs to be in decimeters cubed. So to change this, we must divide it by 1,000. So it becomes 0.04 decimeters cubed. Okay, so I'm going to go start a new, redraw the table. Same setup, moles, volume, conc for concentration. 5, 0.04, and I do my sum. So instead of doing moles divided by volume equals concentration, I do concentration times volume. So I get the moles as 0.2 moles. Now, how do I fill in the rest of the other side? Well, in a question or in your experiments, you'll know how much alkali you're using. So in this case, we're going to say it's 25 centimeters cubed, or in decimeters cubed, that's 25 over 1,000, which is 0.025. And that's as much as you'll know, but from the equation, we had 2 moles of NH3. If you look, go back, pause the video, go back, check. There's 2 moles of NH3 for every 1 mole of H2SO4, because that's why we balance the equation to get that. So that means if we had 0.2 moles of H2SO4, we'd have to have twice as much. 1 mole of H2SO4, 2 moles of NH3, so 0.2 moles of that means we just double it for the NH3. So the NH3 moles is 0.4. And now that I have both the 0.4 here and the 0.025 here, I can do moles divided by volume. Again, remember it's moles divided by volume equals the concentration. So 0.4 over 0.025 gives me a value of 16 moles per decimeter cubed. So to sum up, step 1, chemical equation, balanced. Step 2, the table, and fill in what you know. So table has moles, then volume, and then conc, with the 2 headings of the 2 things you're using, there and there. Fill in what you know, work out what you can, so use volume times concentration gives you moles. Get the second molar value from the balanced equation. I'm going to take it back a minute. First thing you have to do, draw the table, fill in what you know, but step 3 is to convert any volumes into decimeter cubed. Step 4, use moles divided by volume equals concentration to fill in what you can again. So you might have done, at this point you might have done that one, that one, that one, and then use stage 4 to work out this. Stage 5, work out the other mole value from the balanced equation. So then you would work out that, and then stage 6, so that's supposed to write it on the screen, but you do moles here divided by volume here, and that will give you your final value for concentration. So every time, every question, the problems you get in the lesson, you need to use this table.